So this is the same example, just that this time around we want to use the quadratic or the second order. Is that okay?
Okay, now let's look at this example. But in this case, you are going to consider what? The quadratic. The quadratic. So you are using the same example that we solved in the linear to solve the quadratic side. So for the quadratic, we need a second order polynomial. Second order polynomial. And I hope it was stated in the question. Or if the question did not state the second order, then they will ask you to find the quadratic interpolant. The quadratic interpolant. So either you have to find the second order or the quadratic. They are all the same. So we know that the quadratic has been given as y equals a naught plus a1 x. Okay, this one, because we are dealing with velocity, let's do it in terms of t, which is time. So v of t equals a naught plus a1t plus a2t squared. So this is what? A quadratic. This is a quadratic. Now how do we solve a situation like that? We have 1, 2, 3, a naught, a1, a2 to find. And because it is quadratic, our n is what? 2. And we said that if our n is 2, then we are talking about a quadratic. But it will pass through n plus 1 data points. So it means that this will give us 2 plus 1, which is what? 3 data points. It means that we are going to pick 3 points from the table. 3 points from the table. So how do you do that? It's very simple. Very, very simple. Okay. When we are dealing with the linear, I forgot to add something. I'll add it to the polynomial, the quadratic at the end of it. So I'll use it to explain to you to understand. So looking at these 3 data points here, we have to pick numbers that are very close to the 16 that we have been asked to find. You want to find v of what? 16. That is when t equals 16 seconds. Is that okay? So now let's look at this. Is 15 is very close to 16, yes? Now let's compare 20. You only need 4 steps to get to 16. That is difference 4. So if you compare this 20 and this 22, 20 is very close to 16. Now 11 is 1. Let's compare the 10 and the 22.5. You only need 6 steps. Here you need, I think the same thing, 6.5. So the 10 will be more closer than the 22. So it means that the point that we are going to pick here is t equals 10 seconds, t equals 15 seconds, then t equals what? 20 seconds. So these are the 3 data points that we are going to pick. 3 data points we are going to pick. So we have our data point. Let's consider when v of 10. What do we get? We have 227.04. Also consider v of 15. V of 15, what do we have for 15? That's 362.78. This meter per second, meters per second. Then V of 20. V of 20 we have 517.35 meters per second. Please, I hope you can see that. So this is what you have. So you are just simply going to substitute this one into this. So per what I have here, V of t, let's consider when t equals 10 seconds. What happens? So when t equals 10 seconds, we have 227.04 equals A naught plus T. Where is our T? Our T is 10, so 10 A1 plus 100 A2. I hope you are not confused of the 100 because per this side T is 10, 10 squared is 100. So let's name this one equation 1. Then we move on to the next one. The next one is when T equals 15 seconds. So when T equals 15 seconds, what happened is when T is 15 seconds, we have 3, 6, 2.78 equals A naught plus 15 A1 plus 15 squared is what? 225 A2, equation number 2. Then you consider when T equals 20 seconds. So when T equals 20 seconds, what are we going to have? 517.35 is equals to A naught plus 20 A1 plus 400 A2, equation number 3. Cos 20 squared is 400. So after this, we have 3 equations which is simultaneous, so we solve it simultaneously. And if you do it very well, we have your A naught to be 12.05 okay, so after doing it, well, this is what we have for A naught, A1, and A2. So you simply go back to this. Okay, then we substitute our A1, A naught, and A2 there. So V of T equals A naught, we had 12.05 plus A1. A1 we had 17.733 T. A2 we had 0.377 T squared. If I convert this one to 3 decimal place, that will be 0.377 squared. Alright, so after getting this, we have to find V of 16. How do you get V of 16? We simply substitute in there, so that will give us 12.05 plus 17.733 times 16 plus 0.377 times 16. So our V of 16 is equals to 392.1876 meters per second. Okay, now this is what I was talking about. The data point that we picked, okay, after calculating for this, the answer that you have here, we have to bring or write the range or the domain for the data point that we have. So the data point that we picked to calculate for this thing, we pick it from 10 to 20. Is that okay? 10 to 20. You can also decide to write as 10 is less than or equals to T less than or equals to 20. So we start from 10, 15, and then 20. This and that are the same. So either this or that. They are all the same. Is that okay? So that is how we find for interpolations. So you could see that quadratic interpolant is easy to find when using the direct method. So this is the direct method. So we are going to consider the next method called Newton divided difference. Newton divided difference. Very interesting method to use, and when you use that method you get the same thing, nothing changes. Is that okay? Thank you very much for watching. See you in our next video. Try to share this link to everyone to also enjoy, and subscribe. Most of you have not subscribed, so try and subscribe for me.